Hello guys, this is the new section, Working with Geodata. In this section we will see one of the most interesting features of D3JS, that is, how to work with geographical data. I'll show you all the various map projections provided by D3JS, and also how easy it is to manipulate and enrich maps through D3. Let's start with the first video, Elections 2016 Choropleth. In this video, we're going to create an election map for the 2016 presidential election. We'll colour the results of each individual county based on whether they voted Democrat or Republican. The map will look like this. Additionally, we'll show a list of small cubes below the map that show the results of individual counties. We first need to create a JSON file containing the geometries for the individual states, counties and districts. To get those geometries in the correct format, we will get the geometry from the US Census Bureau, converting the shape files to topo.json, and get the results per county, state and district. We start by getting the shape files. The shape files can be downloaded from the US Census Bureau. Go to this website and download the 500K file, which is the most precise one. The CB 2015 US County 500K shapefile is in ArcGIS format, which contains all the polygons representing all the individual districts in the US. We have to convert this shapefile to a topo.json file. When visualizing data, there are two formats we can use with D3, GeoJSON and topo.json. GeoJSON is the de facto standard for encoding data in JSON, and topo.json is an extension of GeoJSON, which tries to eliminate redundancy and create smaller files and speed up processing. Topo.json comes with a set of tools you can use to convert shapes files to topo.json. So, the first thing to do is install topo.json. We can just install it using this command. This installs the topo.json and the topo.json simplify packages. These tools, however, work on GeoJSON files as their input. Since we have a shapefile, we first need to convert the shapefile to a GeoJSON file. There is another simple npm package that can help us with this called MapShaper. Let's install that package as well. To test whether the installs were successful, we can run geo to topo v, topo simplify v, and MapShaper v commands. We'll use MapShaper to convert the shapefile to a GeoJSON file, and we'll also extract the unique ID, GeoID. Navigate to your dataset directory. Now let's use MapShaper to get some more information about our shapefile. As you can see, it gives information about the coordinate systems used. Long lat as the PCS and WGS84 as the GCS, and more importantly, it shows the data associated with each record. Here, once again, see the GeoID field, which we'll use to identify the records in our GeoJSON and topo.json files. To limit the size of the resulting file, we'll also remove all the other attributes except the name and GeoID one. For that, we use this command. This file now contains all the correct data, but the file size is 29 megabytes. So we'll use the topo.json tools to shrink this file to a more acceptable size. With the conversion to topo.json, we've reduced the size from 29 megabytes to 2 megabytes. We first use geo to topo to convert the input to topo.json. By playing around with the Q value, we define the coordinate precision we want to keep in the result. This means that the lower this value, the less distinct coordinate we're left with. After this conversion, we pipe the data to topo simplify, where we further reduce the size. We can once again play around with the S parameter to specify how aggressive the simplification should be. If you're interested in the technologies behind these two tools, you can look at the article from here. While 2 megabytes might seem like a large file, if you serve this file using a web server that supports gzip file format, the actual file size further drops to around 400 kilobytes. Now, there's a project on GitHub which collected the results from various sources and combined them for the country-level election results in a single download. From this GitHub repository, download the 2016 US County-Level Presidential Results.csv file, which contains all the results for each individual district. Just note that, for Alaska, there are no county-specific results, so we'll use the statewide results. This is the entire data. As you can see from the header, we've got a lot of information we can work with. For this example, we'll use the per Dem, per GOP fields to determine the colour of each county. The higher the difference, the more pronounced will be the colour blue for the Democrats and the colour red for the Republicans. Moving on to the visualization, we visualize the data in 2 different ways. We show it as a map and as a set of small cubes. First, we'll look at the steps you need to take to show the map. The first we do is set up some scales and helper functions. Here we see 2 features provided by D3 that help us in showing geodata. With the D3 GeoAlbers USA function, we tell D3 that we want the geometry rendered using the Albers USA projection coordinate system. With the D3 GeoPath function, we convert JSON in GeoJSON format to a set of SVG paths. Besides the geo-specific parts, we also create a scale, which we use to map the percentile difference between Democratic and Republican votes. We use 4 colours in the scale, so that the Democratic colours are always bluish, and the Republican ones are always reddish. The map-related data is already in the correct format, and we don't need to change much for the election results. The only thing we do here, after loading the data using D3Q, is convert some values to numeric ones. We also create a key value map, so that we can get the data by just using the ID. Once all these preparations have been done, drawing the map is really simple. Here, we bind the topo.json data we created at the beginning of this section. By calling topo.json feature, we convert the topo.json data to GeoJSON. By just calling path D, we can now convert the GeoJSON feature to a SVG path, which can be assigned to the D attribute. The colour of each district is based on the scale we defined. We do use an additional check. When we can't find the ID of the geometry in our data KV map, we return a grey colour denoted by this CCC. At this point, we run this example. We can already see our map. The next part we add are the cubes at the bottom. Here we first create a D3 scale band, which we use to correctly position 100 cubes next to one another. Next, we just iterate over all the election data and draw the rectangles based on the grid band. Note that we also add a data state attribute to the rect we create. When we now run this example, you'll also see a set of rectangles at the bottom. Just having those rectangles at the bottom doesn't really add much, so let's add some interaction. To add interactions, we add a number of listeners to the rect we just created. In the mouse over listener, we first add the selected class to the element we're hovering over, which adds a black outline. We also select the element with ID #CID, and then the unique ID of that country. This will select the correct country from our map, and also set the selected class to that element. Next, we change the opacity attribute of all the rectangles to 0.3, and directly change the opacity attribute of the rectangles that have the correct data state value to 1. Finally, in mouse over, we add some output text, showing the details of the selected county. In mouse out, we just reset the values we made in mouse over. The result is an interactive map, which you can use to see the election details of specific counties. So we used Alba's USA projection in this video,